Hi guys, today I'm doing Khan Academy, the rock cycle, and understand the rock cycle. Let's go.
Tried to hold a staring contest with a rock? If you did, you might not have expected that all that time you were staring at one of the sneakiest shapeshifters in the world. No, rocks don't shapeshift into unicorns, but they do change shape and composition. Sometimes they change quickly, like when an erupting volcano launches molten rock into the air. And sometimes they change slowly, like when a rock is heated and compressed in the earth for thousands to millions of years. When geologists stare at a rock, they can figure out the rock's composition and tell the story of how it was created. And it turns out, rocks can be made in many different ways. When put at the right combination of heat and pressure, rocks can become molten and liquid. When this molten rock cools and becomes solid, we call the rock it makes igneous rock. This term comes from the Latin word igneous, which means fiery or burning hot. Igneous rocks make up more than 90% of the Earth's crust. One common kind of igneous rock is granite, which you've probably seen in bridges, buildings, and countertops. Another kind of igneous rock is obsidian, which is smooth and glassy, and is sometimes used to make knife blades. Both of these rocks were made of molten rock. So why do they look so different? Well, granite was made from magma, which is molten rock that exists below the surface of the Earth. Magma tends to cool slowly underground, which gives time for the elements in it to form large crystals. And this obsidian rock was made from lava, which is molten rock that flows above the ground. Lava tends to cool quickly, which causes the rocks it forms, like obsidian, to have smaller crystals. I always remember the difference between magma and lava like this. I keep my lava lamp above the ground, just like lava is above the ground. If I buried my lava lamp in the ground, then I can call it a magma lamp. Once an igneous rock is created, its journey isn't over. The rock might begin to change through a process called weathering. This is when water, weather, wind, and other physical forces chip away at a rock and cause little pieces to break off. These little particles are called sediments. The sediment from our igneous rock can be moved around by wind and water. This is called erosion. Eventually, the sediment will settle down somewhere, maybe at the bottom of an ocean or a lake, and it might join other sediment from other rocks, crushed up shells, and plant matter. And over time, this sediment will become a rock. Rocks that are formed from sediments are called, you guessed it, sedimentary rocks. But how does sedimentary goop at the bottom of a lake become a rock? Well, it goes through a process called lithification. Lith comes from the Greek word for stone. So you can think of this process as stonification. The first step of lithification is called deposition. This is when sediment is deposited in a new location, and it spreads out to form a layer. As more and more layers are created, the layers underneath them become squished together. This is called compaction. When water moves through the layers of sediment, it can carry dissolved minerals with it. The water can leave these minerals in between the sediment particles, which makes everything stick together. This cementing of sediment is called cementation. Limestone is a sedimentary rock that is made when sediment that contains a lot of calcium carbonate in it goes through lithification. But once a sedimentary rock has been created, it doesn't mean that it is done changing. Sometimes a rock is squeezed or heated so much that the minerals inside it actually change composition. It is now a metamorphic rock. You might have heard of the word metamorphosis, which describes when something changes from one form and structure to another, like when a caterpillar turns into a butterfly. Metamorphic rocks are made when igneous, sedimentary, or even other metamorphic rocks change form and structure because of heat and pressure. For example, when the sedimentary rock limestone gets put under a lot of heat and pressure, it can turn into marble. But metamorphic rocks still might not be done changing. Rocks can actually keep on changing forever. Igneous and metamorphic rocks can become sedimentary rocks if they are broken apart into sediments and go through lithification. And metamorphic rocks and sedimentary rocks can become igneous rocks when they are melted and then cooled. And igneous rocks and sedimentary rocks can become metamorphic rocks when they're exposed to high heat and pressure. This is called the rock cycle. So maybe next time you get the chance to stare at a rock, see if you can figure out whether it's igneous, metamorphic, or sedimentary. And when rocks change so much, who knows what kind of rock it'll be next?
What? The The rock cycle describes how rocks on Earth form and change over time. When rocks are pushed deep below the Earth's surface, they melt to form magma. The magma that reaches Earth's surface through volcanic activity is called lava. Igneous. What did I just. What? Oh, there. Weathering breaks igneous and other types of rocks into smaller pieces, called sediment. Sediment erosion transports sediment from one place to another. Deposition drops sediment in a new location. Sedimentary rocks form when sediment is compacted and cemented. This process is called lithification. Metamorphic rocks exist when formed when existing rocks are exposed to intense heat and pressure. Metamorphic rocks can be formed from igneous, sedimentary, or even other metamorphic rock. This rock formation, Uluru, in Central Australia, is made up of sedimentary rock called sandstone. Image credit Uluru Sunset by Wave CC01.0. Now let's get to this. That took 2 minutes. Okay. Pumice is a highly porous volcanic rock. It forms when lava containing large amounts of dissolved gas is ejected from a volcano. As the lava cools and hardens, the gas escapes, forming bubbles that are preserved in the solid rock. An image of pumice is shown below. Pumice rocks can float, I think. What type of rock is pumice? Igneous. During the rock cycle, sediment rock is created when wind or water breaks down existing rock. Which process does this best describe? Weathering. During the rock cycle, sediment is created when wind or water weathering. Next. How do sedimentary rocks form? Through the lithification of small pieces of rocks and shells? Yeah, that's right. Which statement correctly describes the difference between magma and lava? Magma is located in the Earth's interior. Okay. Wow, amazing, a 2-win streak now. Your dedication is blazing. Cool. Proficient. Up next, lesson 2.
Have you ever wanted to travel back in time? Would you go meet your younger self? Would you go and ride a dinosaur? Or would you meticulously create a timeline of the Earth's 4.6 billion year long history based on major geological events? Even though geologists can't go back in time, they've been able to do just that. Their timeline is called the geologic timescale, and it breaks up all of Earth's history into units called eons and eras. And you might be wondering, how can we map out what happened on Earth billions of years ago? The answer is rocks. Geologists look for clues in sedimentary rock layers, which we call strata. The fossil record, which are the remains of organisms that have been preserved in rock layers, can give us glimpses of creatures that breathed long ago. Also, the difference in mineral composition in different rock layers can tell geologists when a volcano erupted or an asteroid hit. But how do geologists know when one rock layer is older than another? Well, when sedimentary rocks form, they are deposited in layers, one on top of the other. So, unless the layers are disturbed or turned over, the layers at the bottom are always older than the layers at the top. Geologists call this rule the law of superposition. So, if a geologist finds a fossil of an ammonite in a layer of rock above a fossil of a Dunkleosteus, the scientists would know that the Dunkleosteus is older than the ammonite. This process is called relative dating, because it helps scientists determine the relative ages of rock layers and fossils. But what does relative ages mean? Let's say that I told you my friend Ava is younger than her sister, but older than her cat. Then I wouldn't be telling you Ava's exact age, but her relative age, in relation to her sister and her cat. Let's take a look at another example of relative ages, this time with rocks. Imagine that one day you found a big rock with many layers like this. Because the rock is a sedimentary rock, and you remember the law of superposition, you know that the layers at the bottom are older, and you know that the layers up here are younger. But what about this section of rock, right here, that slices through all of the other layers? Geologists would call this section an igneous intrusion, since it was formed from molten rock that is cooled. This particular igneous intrusion isn't clearly on top of or below any of the sedimentary rock layers, so we can't use the law of superposition here. Luckily, geologists have figured out another rule called the law of cross-cutting relationships. This rule says that when two geologic features cross or intersect, the feature that cuts through the other is younger. And this makes sense, because you can't break something before it even exists. So since our igneous intrusion cuts through the layers of the sedimentary rock, we know that it must be even younger than the rock layers. And what about this fault or break over here? Well, since it slices through all the layers, as well as the igneous rock, the law of cross-cutting relationships tells us that the fault must be the very youngest geologic feature here. Other pieces of evidence, like fossils, can be used for relative dating. For example, suppose a geologist found a rock containing fossils of extinct organisms, and another rock that contained fossils of modern organisms. The geologist could then deduce that the rock with the extinct organisms is older. Certain kinds of fossils, called index fossils, are especially helpful when determining the relative age of a rock. Index fossils are fossils that are only found on a specific section of the geologic timescale. I always remember what an index fossil is, like this. Just like I use my index finger to point to give directions, index fossils can point to when on the geologic timescale a rock was formed. So if a geologist finds the same index fossil in rock layers in two different rocks, they know that those rock layers must have been formed around the same time period. But fossils aren't the only thing that can help geologists figure out a rock's relative age. For example, if a geologist found two rock layers that contained evidence of the same geologic event, like a layer of ash from a major volcanic eruption, the geologist could deduce that those rock layers were made at the same time. Relative dating is how geologists figured out that stegosauruses were extinct long before T-Rexes even existed. It also helped them figure out the first single-cellular life formed about 3.8 billion years ago, and the first multicellular life formed about 600 million years ago. And they figured out that modern humans didn't even exist until about 200,000 years ago, which is right at the very end of the geologic timescale. In other words, it took a really, really long time for life to evolve into what it looks like today. We humans are very young in the grand scheme of the Earth's history. Now, if you'll excuse me, I'm gonna go saddle and ride the Spontosaurus.
Okay, bye-bye. That's all for today. Please like, subscribe, and hit the notification bell. Bye-bye.